Hi students, in this video we are going to discuss about prism. In video 2 we have discussed about refraction through a glass slab and we found that angle of incidence and angle of emergence of the ray are the same because the slab is having parallel phase. The same way in this video we are going to find out what is the relation between angle of incidence and angle of emergence for a glass prism. So let us see what is a prism. A prism is a wedge-shaped portion of transparent refractive medium bounded by two plane faces inclined to each other at certain angle. It is a wedge-shaped transparent refractive medium which is bounded by two plane faces inclined to each other at an angle. Okay. So imagine we have a prism. A, B, C, and a ray of light is incident at the face AB of the prism at point Q. So, PQ is our incident ray. Now, what happens when a ray of light incident on a rarer, denser medium interface? It gets refracted, reaches another phase, such as the phase AC at point N. Again it gets refracted. Okay. Now next we are going to find out what is the angle of incidence, emergence, etc. So that what we have to do, we have to draw a normal. I'll take this point as R, okay, and this point as N. Now the angle between angle of incidence and normal is, sorry, the angle between incident ray and the normal is taken as I. And the angle between the refracted ray and the normal is taken as R. Now in this phase, the angle between the incident ray and the normal is taken as R dash, and the angle between the emergent ray and the normal is taken as E, angle of emergence E. So we have angle of incidence I, refraction R. Again angle of incidence is taken as for this phase as R dash and angle of emergence as E. Now next we are also going to find out where is the angle of deviation. For that, if the ray was not refracted, travel in a straight path. Similarly, the emergent ray without any deviation means will travel in a straight path and these two lines meet at a point, and this angle is angle of deviation denoted by the letter delta. So this is the angle of deviation denoted by the letter delta. Okay. Now we are going to derive what is the relation between angle of incidence, angle of emergence, angle of a prism, and also angle of deviation. This is angle of prism taken as A itself. Now from the quadrilateral, A, Q, N, R. Here this quadrilateral A, Q, N, R. You can write angle A plus angle Q, N, R is equal to 180 degree. Angle A plus angle Q and R, opposite angles, equal to 180 degree. And also from the triangle Q and R, this triangle, from triangle Q and R, you can write from triangle Q and R, the total angle is equal to 180 degree. So we can write R plus R dash plus angle Q and R is equal to 180 degree. This is equation 1, this is equation 2. Now if you compare equation 1 and 2, we get, comparing equation 1 and 2, we get angle A is equal to what? Angle A is equal to R plus R dash. So angle A is equal to R plus R dash. This is our first main equation. That gives us equation 3. Okay. Now, from the triangle MQR, this triangle, we can say exterior angle, that is delta, is equal to sum of opposite interior angle. So, from triangle MQR, exterior angle delta is equal to sum of opposite interior angle, that is MQR plus triangle MRQ. But we don't know what is MQR and we don't know what is MRQ. So what we are going to do is, just look at this diagram. This is angle I, isn't it? So this much will be equal to angle I, which means from the diagram, angle I is equal to angle MQR plus angle R. So angle MQR plus angle R. Or we can write angle MQR is equal to I minus R. Okay, this will take us equation 4. Equation small letter. Any number you can put for the equation. Okay, it's up to you. Similarly, from this side we can say angle E is equal to angle MRQ plus R dash, or angle MRQ is equal to E minus R dash. This is equation B. So next step is substituting the value of A and B, equation A and B in equation 4. Substituting equation A and B in equation 4, we can write delta is equal to I minus R plus E minus R dash. On rearranging we can write I plus E minus R plus R dash. But according to equation 1, what is R plus, equation 3, what is R plus R dash? R plus R dash is angle of the prism A. So, from equation 3, that is angle A is equal to R plus R dash, we can write the above equation as delta is equal to I plus E minus, instead of R plus R dash, what we can write? We can write it as angle A. Or on rearranging we can write delta plus A is equal to I plus E. This is the equation which relates angle of deviation, angle of a prism, angle of incidence and angle of emergence, and hence we can conclude for a prism, angle of incidence plus angle of emergence is equal to angle of deviation plus angle of a prism. That is, sum of angle of incidence and angle of emergence is equal to angle of the sum of angle of deviation and angle of a prism. Now let us see what are the factors on which angle of deviation for a prism depends. Factors on which deviation depends. It depends on, first thing, angle of incidence, second, it depends on wavelength of light, third, it depends upon refractive index of the medium, It depends upon angle of incidence and wavelength of light used, material or refractive index of the prism, and also angle of the prism. So let us just rewind what all steps we used. First, we consider the quadrilateral A, Q, N, R, A, and from there we wrote angle A plus angle Q, N, R is equal to 180 degree opposite angles. Then we took the triangle Q, R, N, and we got R plus R dash is equal to, and we compared and we got R plus R dash is equal to angle A. And also from the triangle MQR we got exterior angle is equal to sum of opposite interior angle, and we converted that particular equation in terms of IR and R dash and E, and we got the final equation as sum of angle of incidence to the angle of emergence is equal to angle of a prism plus angle of deviation. Okay. Next, we are going to draw a graph relating angle of deviation and angle of incidence. Okay, we are going to draw a graph relating angle of deviation and angle of incidence. So, angle of deviation and angle of incidence. And when you draw a graph, you will obtain a shape like this. Okay, when you are drawing the graph relating angle of deviation with angle of incidence, you will get a graph like this. And from the graph, it is clear that as the angle of incidence increases, what happens? Angle of deviation decreases. It reaches a minimum value, and after that it keeps on increasing. As angle of incidence increases, angle of deviation decreases, reaches a minimum value, then again an increase in angle of deviation, incidence will increase the angle of deviation. And also for same angle of deviation, you are able to get two angle of incidence, which means for same deviation angle, there is two angle of incidence and hence angle of emergence. This is a graph which relates angle of deviation with angle of incidence. It shows that for a single angle of deviation there are two values of angle of incidence and hence angle of emergence, and also as the angle of incidence increases, what happens? Angle of deviation first decreases, reaches a minimum value, then it increases. Next, we are going to find out the relation between refractive index, angle of a prism, and angle of minimum deviation. Angle of not angle of deviation, is the angle of minimum deviation. Now usually if you draw a diagram, ray diagram for a prism, you will see that when the ray hits the first phase of the prism, it undergoes refraction, then it reaches the other surface, again it gets refracted. So this is R and this is R dash, but R and R dash will not be equal. But there is a certain case in which R and R dash becomes equal. Now I told you, as we are increasing the angle of incidence, what happens? Angle of deviation decreases, reaches a minimum value, from where reaches a minimum value, then only it increases. Now, the point where angle of deviation becomes minimum, at that particular condition, what happens? The ray QR, the refracted ray QR, will be parallel to the base of the prism, and in that particular case, R will be equal to R dash. Angle R will be equal to angle R dash when at the point of minimum incidence, at the value of minimum incidence, minimum deviation, what happens? The refracted ray QR will be parallel to the base of the prism, and hence R will be equal to R dash, and also angle of incidence will be equal to angle of emergence. If these two conditions are satisfied, then the angle of deviation can be said as angle of minimum deviation, denoted by the letter delta m. So, angle of minimum deviation means it is a minimum angle of deviation at which you can say R is equal to R dash, I is equal to E, and delta can be represented as delta m. Now, using Snell's law, what is Snell's law? Snell's law is mu is equal to sin I by sin R. We are going to find out the relation between refractive index, angle of prism, and angle of minimum deviation. For that, we are using equation 3 of the first derivation of prism, that is A is equal to R plus R dash. Now, at minimum deviation angle, what happens? R will be equal to R dash. So, we can write A is equal to 2R, or R is equal to angle of a prism divided by 2. Similarly, using the relation I plus E is equal to A plus delta M. In this case, I is equal to E at minimum deviation angle, and the deviation angle can be written as delta M. So, we can write the above equation as 2I is equal to A plus delta M, or I is equal to A plus delta M divided by 2. Now, substituting the value of I and R in Snell's law, that is mu is equal to sin I by sin R, can be written as sin A plus delta M divided by 2, the whole divided by sin A by 2. Now, this is the equation which relates refractive index with angle of prism and angle of minimum deviation. Thank you.